This is video number 2 for section 8.5, Examples of Solving Rational Equations. I just want to work a couple more example problems for you. These will be a little messier than the ones I did on the last video. Once again, here is a rational equation. We're just trying to solve for x, get x by itself. First step, we said, is to find the LCD because I would like to clear the fractions here. Well, in order to do that, I need to factor the denominators. Looks like this first guy does not factor, just an x plus 1. The second guy also does not factor, x minus 1. The third one, though, that's a difference of squares, so that would factor a plus b, a minus b. And I'm kind of done with that previous denominator. Now I look at all my factors and do the grocery list thing. I just need to make sure that each one is covered. I only have two types. I only have x plus 1s and x minus 1s, and actually it's pretty easy because nobody needs more than one of anything. This first guy needs only one x plus 1. This guy doesn't need any. This one only needs 1. So 1 will be fine, and nobody needs more than one x minus 1 as well. So the LCD is just take one of each. What am I going to do with that? I'm going to take this entire equation, all three terms, and I am going to multiply by that LCD, that x plus 1, x minus 1. Again, I think your best bet is to physically write this thing next to each of those three pieces. It does require a little bit of writing, but I think it's your best strategy for getting the answer right. So let me recopy the equation with just a little bit more room next to each term. And then next to each term, I'm going to multiply by that LCD, that x plus 1, x minus 1. When I have a fraction, I always like to write it over 1 just to kind of help my brain think about what's going on. Here's another x plus 1, x minus 1. I just find that if people try to do it all in their head, they just make a lot of mistakes. So just take the time, write it out, and now you have the advantage that in all three situations, you can physically cancel out the common factors. Remember, only factors cancel out. So when I look at this first guy, I have an x plus 1 down here at the bottom, and I have an x plus 1 at the top. Great, that's gone, leaving me with 1s. In a second guy, I have an x minus 1 on the bottom, canceling the x minus 1 at the top. In the third one, boy, this is the best one. The x plus 1s go, the x minus 1s go. Look across the bottoms here, all 1s. No fractions. That is the whole point of this, is you are clearing the fractions. All that's left is to sort of put the pieces together. So from the first guy, I have the 4x and the x minus 1. I'm just multiplying across. In a minute, I'll do the multiplication. I'm just writing it down. Then I have minus. That minus is important. Minus these two guys multiplied. So the 3x plus 1 times the x plus 1. And then on the other side, I think the only thing I have left is the 8. And so I'll just write that down over here on the right. Okay, once the fractions are gone, then I kind of start over and I say, well, what kind of equation is this? Is this just an easy kind from chapter 1, 2, 3? Is it a quadratic? Maybe it's a little hard to tell, but hopefully you can see that when I start getting rid of these parentheses, I'm going to get some x squareds. So this is definitely a quadratic equation. So I'm going to have to use some of the methods that we learned in chapter 7. The first thing is it's just way too messy, so let's get rid of some of these parentheses. This would be distributing, so 4x squared minus 4x. Be careful with this next part. You have a FOIL problem here, but because of the subtraction, that entire answer to the FOIL problem needs to be subtracted. So keep it in a parentheses to indicate that. I've got 3x squared from the front guy. Let's see, the outer is a 3x and the inner is a 1x, so that's going to make 4x's in all from that. And 1 times 1 would be 1 for the last, equals 8. And then to get rid of this parentheses, I'll go ahead and distribute this minus sign through all of these pieces. So front part here stays the same, and then I have minus 3x squared minus 4x minus 1 equals the 8. That was me taking this negative and distributing it to all those three pieces. Okay, things are looking better here. I think I have some like terms now. So I've got 4x squared minus 3x squared is x squared, minus 4x and another minus 4x is minus 8x, and then minus 1 equals 8. And then I have to decide how to tackle this. Pretty much my choices are the factoring method, if possible, or the quadratic formula, if that doesn't work. Either way, I'm going to have to get that 0 on one side. So let's go ahead and do that. That gives me x squared minus 8x minus 9 equals 0. And then, I always figure if I can factor it, I should. That would make the math work out easier. So let's see here. Is this guy factorable? If it is, it would be somebody's FOIL problem. 3 terms. There's no GCF to pull out. The front would have to be x times x. It's the only way to make x squared. The back is a 9, so I guess you could have 3 times 3. You could have 1 times 9. I'm thinking it's got to be a 1 and a 9 if I'm trying to make an 8 here in the middle. Then I just got to think about the signs. Let's see, I want the 8 to be negative, so negative 9x plus 1x does it. Negative 9x plus 1x, yep, negative 8x. 1 times negative 9 is negative 9. And then when I use the zero product principle, either this guy is 0 or this guy is 0, I'm going to end up with two answers, x equals negative 1 or x equals positive 9. Again, by the time you get down to here, you have done a lot of work, and I know it's tempting to just type those answers into the computer and move on, but you can't draw a box around this until you check that defined issue, that bad x issue. So you've got to go back up to the original equation. My x candidates are negative 1 and 9. You got to go back up to the original. Let me clear us some room here. And you've got to take those candidate answers, the negative 1 and the positive 9, and you've got to see if they're going to be okay. So let's start with the negative 1. Remember, you're just checking the denominators. As long as the denominators are fine, you're going to be fine. Well, right off the bat, negative 1's no good. Negative 1 plus 1 is 0. Forget it. That's bad. So I'm going to have to throw this one out. How about 9? Let's see. That would make a 10. That would make an 8. 9 squared is 81. Minus 1 is 80. We're just fine with the 9. So this equation actually only has the one answer, x equals 9. The only other bad x, I think, would have been a positive 1, right? Would have made this guy problematic. The back guy is problematic either for negative 1 or positive 1. So you could have identified that from the very start. In any case, now that I have it, I go back down here, I throw out the negative 1. The final solution to this problem is just x equals 9. If I had to throw both of them out, then I would have just stopped and said no solution. Okay, let's try another example then. This one has just a bit of a trick to it, and that's the reason I wanted to show it to you. Just another rational equation. As soon as I see this, I think, oh, I want to get rid of those fractions. You haven't been able to get rid of the fractions in the last few lessons because when you add, subtract, multiply, divide fractions, you get a fraction. That's just the way it is. But when you solve an equation, you can wipe out the fractions. First step, find that GCF. Let's see, this guy doesn't factor. This guy doesn't have a denominator. The second guy, I can pull out an x. And then I'm looking at this, trying to figure out the LCD. It looks like I have 3 different types of factors, and that is technically true. But remember, we've had this issue before where if you have the subtraction thing and they're just backwards from each other, you can fix the one that looks backwards to match the other guy. So I would take this 2 minus x, and I would actually factor a negative out of there. What's that going to do? It's going to make the negative x a positive x, and it's going to make the positive 2 a negative 2. And now it makes my LCD a lot easier. What am I going to do with this negative sign I pulled out? Well, if you have a negative sign on the bottom like this, you can either move it to the side, or in this case what I'm going to do is I'm going to move it to the top. That turns out to be the best spot to move it to. Let me rewrite what I have now. So that negative went to the top, and the bottom is now x minus 2. The second guy is just the 1. And the third guy is all factored with the x and the x minus 2. My LCD, I only have two kinds of factors now, and nobody shows up more than once anywhere. So I can just take one of each. That'll be just fine, x and x minus 2. And then I take that LCD and I multiply the entire equation by x minus 2. Once again, I think your best bet is to physically write it out. So let me go ahead and do that. Okay, so I recopied the equation, and then next to each term I just wrote times x minus 2, times x minus 2, times x minus 2. Now I can do my physical slashing here, so in the first multiplication the x minus 2's drop out. The second one, nobody drops out. The third one, everybody drops out. The x's are gone, the x minus 2's are gone, leaving me with all those 1's. Look across the board, there's no fractions anymore. That was the whole point. Let's see, from this first guy, the only thing that's left is x times negative 1. X times negative 1 is negative x. From this guy, it's just x times x minus 2. I might as well work that out. That would be x squared minus 2x. And from the other guy, everybody went out. I just have 1. Once again, I got a quadratic equation here, so I'll need to solve that in the standard quadratic way. I've got x squared minus 3x equals 1. I need to get that 0 on one side, so let me subtract 1 to the other side. And then I just think the same thing as before. If I can factor this, that would be great. I think the problem, though, is that it doesn't work, because this would have to be x and x. This would have to be 1 and 1, but there's no way you're going to make a 3 out of that middle part. So I tried the factoring, it didn't work, and so that means I'll have to go to the quadratic formula. Let me write it down with all the slots. Okay, so here's the quadratic formula. I'm filling in b to the first two slots, and then a would be 1, c would be negative 1, a would be 1, and then I just need to start cleaning up here. Let's see, this would be positive 3. Inside the square root, that's a 9. These two guys would plus out, so 9 plus 4 would be 13. And then the bottom would be 2. So I have two answers, but I'm not sure they're the right answers, right? Because I have to make sure they're not bad x's. Now this may be harder to tell without going to the decimals. So let me grab my calculator and see what the decimals are. There would be two, one for the plus and one for the minus. So I got 3.303 and negative 0.303. Before I box those answers, let's go back up to the original equation. I just need to make sure that nothing bad is going to happen. I think we're safe, right? Because I'm looking at this thinking the only bad x for this guy would be a 2. If I filled a 2 in there for x, that would be bad. Let's see, this guy, a 2 also would be bad here, and then it looks like 0 itself would be bad. Well, I didn't get anything like that. I got these weird decimal things, so I'm just fine. My answers are fine. Just pay attention to the instructions. If they want the exact answers, you would give this, and if they want the decimals, then you would give this.